of 4, positive or negative? That's my page 6 coming up. Is f of 4 positive or negative? So what am I given? I'm given, perfect. So I will draw a vertical line at 4. So this is x equals 4, the vertical line. It crosses the graph in this point. So now the question is the function value at 4 positive or negative? Right, because the graph is under the x-axis. Very good. So I'm going to say negative, not positive. Good. The next question. Is f even, odd, or none of the above? Symmetric? That's the question. Odd, even, or not? Let's look at the graph. Is this symmetric with respect to the y-axis? No. It would have been if this were not a full point, and it would have continued here, or this would have been a full point. So it's not even. Is it odd? No. So what do we conclude about this function? The function is not symmetric. Last question. Okay, I have to explain the last question here. So we looked at two different situations, two different properties of functions. One was increasing, decreasing, and constant. The second property was if a function is symmetric with respect to the y-axis, which means even, or symmetric with respect to the origin. It can be this way or it can be this way. Still symmetric with respect to the origin. So now let's take a look at another very important situation. And this is called max-min. There are two different situations, two different types of max-min. One of them is relative. In some books, you will find it as local. And the second possibility is absolute. Absolute or global. I'm going to draw a function, and then we'll come back to finish that one in a minute. So here's a function. Very simple situation. And let's say it ends here and it starts here. I don't want you to get the impression that they have to be the same, so I'm going to change that. I don't want you to think that they have to be at the same height. That's not connected at all to that. No connection. Okay. Okay, so I see that the function is definitely increasing till it reaches this point, right? Agreed? I see that the function is definitely decreasing till it reaches this point. I'm going to say this is 5, and let's say this is x equals 10. And then obviously then it starts to increase. This particular point is called a maximum, and it's a relative or local maximum because I can show an open interval around it where all function values are smaller than that function value. This is the highest. And I can show the open interval that shows that all these points are lower. They have a lower height than this one. So you want to choose relative, or you want to use relative or local? It doesn't matter. Local is, they're both used interchangeably. You prefer relative or local? Relative, okay. So this is a relative max. Now, is this point an absolute or a global max for this function? Yes, because there is no other point anywhere that is higher than it. It starts here and it ends here. So this relative max is also absolute max. Okay, now can anyone tell us what does this point represent? Of course, 10 comma f of 10. What will this represent, this point? Definitely a relative, yes, and definitely an absolute. It's relative because I can show the open interval such that all functions' value are strictly greater than this one. What about this point? This point cannot be a local because I cannot show the open interval on both sides. So the endpoints of the interval can never be local. They could be global, but never local. Never relative. Max or min, the endpoints. Now, if I graph the function like this time, this is a relative max, and also, and it's not a global max because this is the global max. But this is not a relative max because I cannot show the open interval on this side. But what about this? This is a relative minimum, but it happens to be a global minimum as well, because there is no other value smaller than it. Okay, so now the question here was asking us, is the final question. They say, is f of 2 a relative max? That's the final question here. Is f of 2 a relative max? So in some books, the equal symbol is accepted for relative max and min. In this book, the equal symbol is not, meaning that they want to show that this is not a relative max because these values here are at the same level with this. If it were like this, then I would have said yes, because all functions' value left and right are smaller, so this is a relative max. But because on this side the function is constant, your book says no, this point is not a relative max. I can show you the calculus book. The calculus book, they include the equal symbol as well, and they consider that as being a relative max. It's not a big deal. I accept both. Okay, so let's summarize. We looked at 3 different things: increasing, decreasing, and constant. We looked at max, min, local, relative, and absolute. And we also looked at odd and even functions, which means symmetric. So this is what we have studied so far in this class today. And what I wanted to do next is talk about what it's called the difference quotient. And then I'll stop. This is a little bit of a refresher of the next section. So let's suppose, coming up. So let's suppose I have a function. This is the function f of x. And I'm going to pick 2 points, one denoted by P and the other one denoted by Q. And both are points on the graph of this function. And I would like you to give me the x and the y, not the x, the y coordinates. I'm giving you the x coordinate, and I would like you to give me the y coordinate. This distance is very tiny, but you can say, but it is huge in your graph. True. But if it doesn't look huge, I will not be able to explain. Okay, so this is x, and this is x plus a little bit. For example, if this is 1, this could be 1.3. If this is 10, this could be 10.1. So this distance is small. So now I would like you to give me the coordinate, the y coordinate of P and the y coordinate of Q. Of course. And the other one? Very good. Awesome. Thank you, Marcus. So we do have those coordinates. So P has coordinates x comma f of x, and Q has x plus h comma f of x plus h. Agreed? The next step is I will draw a line segment through these 2 points. And I want you to refresh our memory on how to determine the slope or the steepness of this line. Can anyone remind us how to determine the slope or the steepness of a line? It is rise over run, which means difference in y's over difference in x. So can anyone dictate? Very good. So it's y2 minus y1 over minus. Very good. So what is x2? So we can write in the denominator. Very good. Awesome. Minus. Very good. Is there anything we can simplify here? Anything? Of course. I was just waiting. It was a tricky question. No. This one was a little tricky because I was hoping that no one would say, and no one did, to simplify h with h, or who knows, x with x, but just x with negative x in the denominator. Good. So this is f of x plus h minus f of x divided by h. This is called the difference quotient. The difference quotient. What does the difference quotient represent? It represents the rate of change of f of x between that's it. Good. So let's look at a function. 78 on page 252. And the function is f of x equals x squared minus 5x plus 8. We are asked to find and simplify the difference quotient. I know I only have 2 minutes left. We'll see what we can accomplish. Find and simplify the difference quotient. Allow me to use the abbreviation DQ. DQ, difference quotient. In this class, you don't have to remember the difference quotient. It's very easy, I think, but you don't have to remember it. But in calculus and moving forward, if you are interested, you have to. Okay, so here's the difference quotient, f of x plus h minus f of x divided by h. So this is the dq. We're asked to find it and simplify it for this particular function. So let's analyze for a moment what we have and what we don't. Is this given? Do I have it? I have it. It's there. Here. It's very clear. This is given. Is there anything I can do to a little number, or
is it the b value or the c value? One of those is
no? So this is h. So nothing. I cannot do anything to h. So now I'm asking you this question. Do I have this piece? The answer is no. I don't have it. I have to determine it. I'm given the function, bless you, but I have to determine f of x plus h. That's why I did this last time. So f of x plus h, do not calculate anything, just tell me what to write first for everyone to see.
X squared minus 5x plus 8 plus h. No, yes.
So that's why we emphasized last time how to read a function and what does the pattern say. For this function, the pattern says blah squared minus 5 times blah plus 8. Now I want the blah in there. This is our blah.
So we insert x plus h for all the x.
Exactly. That's extremely important to understand by looking at the pattern. Very good. I'm ready.
Square
Very good. Awesome.
minus 5
Very good.
times x.
Exactly, with parenthesis plus 8. I have 3:15. I'll stop. I just wanted to say that we have to simplify this as much as we can.